video we discussed about is matter pure, that lesson. So in this video we will discuss another lesson, that is atoms and molecules. It is also one of the important lessons in chemistry. So this is the basics of chemistry. So you must and should have to learn this lesson, atoms and molecules. It is very useful for you in further class, that means 10th, intermediate first year, second year. The chemistry subject, it is a little bit easy if you know very well this lesson. This is the main basics lesson for chemistry. So before seeing this lesson, you should read the periodic table, that elements symbols and element names and atomic mass up to 30 elements. You must and should have to learn these three. Again I am saying elements names, symbols and atomic numbers and atomic mass up to 30 elements. You should learn. So then only you can understand this lesson. Okay. So in this lesson we will learn main things are first lesson introduction and laws of chemical combination, laws of conversion of mass and law of constant proportions and Dalton's atomic theory, atoms, modern day symbols of elements, and that means nowadays how that symbols are given for elements, that and atomic mass, what is atomic mass, and molecules, definition of molecules, atomicity and chemical formula, rules for writing chemical formula, what are the rules we have to follow to write chemical formula, and molecular mass, formula unit mass, what is the formula unit mass, and ions and mole concept. These are the main contents in the lesson we will learn. Now see introduction of this lesson. Actually around 500 BC, one Indian philosopher is Maharshi Kanath. He explained about matter. So we know matter means what are the objects we are seeing surroundings, those we can call matter. Fan and wall, even our body, hands, everything that is nothing but matter. So this Maharshi Kanath, he said something about matter. What he said, matter which further device can't be possible, which is known as paramanu. So he said matter. So when we break into matter very small parts, after that in some cases we can't break. For example, now we can break this pen, and after that we again another break, like that. Finally what we will get very small piece of this pen. So after that we can't break down. So that small very small particle we can call paramanu. This is only the smallest particle in our world. That is said by Maharshi Kanath, he is Indian philosopher. But after that, so many experiments, the scientists, two scientists are there. Those are Lavoisier and Joseph L. Proust. They explained clearly about matter. What are the characters? How the properties of that matter? They said after this, they explained about that matter clearly. Lavoisier, the scientist, he explained clearly about the law of chemical combinations. When you are looking this video, you should follow the textbook also. He explained about law of chemical combinations. The chemical reaction between two or more substances give rise to product, which is governed by certain laws called law of chemical combination. That means when two reactants, the chemical reaction between two or more substances, means for example A is one substance and another one B is another substance. When these two are mixed together, two or more substances. See here, I taken here two substances. When these two substances combine together, they form product. They form AB product. This is the example I am saying here. So which is governed by certain laws called law of chemical combination. That means when these reactants combine together, they forms product. Which elements will react and what is the nature of those elements and how that nature of that product, how this chemical reaction will happens, All these are explained related to reactions. All these are explained by Lewis. So here this law of chemical combination, it is giving some laws to explain the reactions, every reaction. What are the laws it is giving? The first law is laws of conversion of mass. This is one type of law. It will explain the clearly about reaction. And another law is laws of constant proportion. This is another law. It is also explaining reactions of chemicals. And another one is law of multiple proportions. And next one is law of reciprocal proportion. And another one is Gay-Lussac's law of combining volume. These laws explaining clearly about the chemical reactions. All these laws are called law of chemical combination. But as per 9th class, you will read about laws of conversion of mass and law of constant proportion. These two topics only you will learn in 9th class. After that, in intermediate, in higher class you will learn about these three laws. So in this 9th class we will discuss only about law of conservation of mass and law of constant proportion. See now the law of conservation of mass. How the definition of that law of conservation of mass means, in here first you have to observe mainly 2 points. The Lewis, how he explained the law of conservation of mass, mainly he gave 2 points about the law of conservation of mass. The first one is during a chemical reaction, the total mass of reactants will be equal to the total mass of the product. Before that reaction, that elements are called reactants. After that reaction, the element that is called product. See here, I gave one example for reaction. A and B. These are arrow mark. This is arrow mark. Arrow mark before it was presented. That means before that reaction, these are A and B. So this A and B we can call reactants because these are happens before reaction. So A is one reactant and B is another reactant. So when these two are combined together, they form AB. This AB is called product. So here during a chemical, the total mass of reactants will be equal to the total mass of the product. So what is the mass that A and that B having? For example, if A is having 2 grams and B is also having 2 grams, so total mass of the product it will be 4 grams. If you do this total, 2 plus 2, what is that? 4 grams. So 4 grams are equal to that 4 grams. So this was said by Lewis. That only here I wrote the total mass. What is that mass of A? 2 grams. What is the mass of B? 2 grams. The total I said. So total you should do total 2 grams, 2 grams. What is that? 4 grams. It will be equal to the total mass of the products. So here A 2 grams and B 2 grams. Total how much? 4 grams. 4 grams, 4 grams. Like that it will equal. This is called law of conservation of mass. And next one, another point also he said, that is mass can be neither be created nor destroyed in a chemical reaction. That means in the reaction we can't destroy and we can't create that reactants. That is also said by law of conservation of mass. See, mass can be neither be created nor destroyed in a chemical reaction. I wrote here one reaction, that is carbon. Carbon is a reactant because it is happened before the reaction. Carbon plus oxygen. That gives rise to what is the product? It gives CO2. So here carbon is reactant and oxygen is also reactant and CO2 is product. Okay. So here what I told here, mass can be neither created. Carbon we did not create. It was happened naturally. And oxygen also no one did not create it. It is also happened naturally. So we did not created oxygen and carbon. So after reaction after reaction we can't destroy even. See here, what is that after reaction, what it will be happens? It turns into carbon dioxide. Is carbon here or not? Is carbon is here or not? So after reaction, did we destroy this carbon? No, we did not destroy this carbon. It will be appear here. And now see, before that reaction, what is there? Oxygen. How many molecules of oxygen is there? 2. So after reaction also, how many oxygens are formed? 2. We did not create a carbon and we did not destroy. After reaction also, we did not destroy this carbon and oxygen. We neither we created nor destroyed. We can't destroy and we can't create, but we can convert into one form to another form. Here, what is that in the form of this C? It is in the form of carbon. What it will be in the form of oxygen. But after reaction, what it will be containing? It is in the form of carbon dioxide. That means the carbon and oxygen we converted into carbon dioxide. So we can't create and we can't destroy, but we can convert into one form to another form. Now we see another law that was in your textbook, that is law of constant proportions. So in the definition of law of constant proportion, in a chemical reaction, compounds always contain the same elements present in definite proportion. So in the reaction, that all elements it will be present in definite proportion by mass, irrespective of their source. Means in the chemical reaction, all elements are having definite proportion based on mass. So by definition you can't understand. So I wrote here one example. So now see one example, that is water. What is that water formula? H2O. So here 2 hydrogens, H2O. How many hydrogens are there? 2 hydrogens. That's why I wrote here also 2 hydrogens. 2 hydrogens are combined with 1 oxygen and it forms H2O molecule. See here, these 2 hydrogens are reactants and oxygen is also reactant because it is happens before the reaction. So these 2 are reactants. When 2 hydrogens are combined with 1 oxygen, it forms H2O molecule. This H2O is nothing but product. So H2O is product and these 2 are reactants. Now see hydrogen mass. Again I am saying, before seeing this lesson, you should read elements atomic numbers and elements atomic mass and symbols of that elements. Then only you can understand these reactions. Now hydrogen mass. Actually hydrogen mass is 1 gram. 1 gram hydrogen mass is. Actually hydrogen mass is 1 gram. But how many hydrogens are here? 2 hydrogens are there. So total mass of hydrogen here 2 grams. And oxygen mass it is 16 grams. So total, if you do this total, then how much it will be? 18 grams. Now see this side also. 2 hydrogens means 2 grams and oxygen mass 16 grams. So totally how much? 18 grams. So before that reaction it is having 18 grams and after that reaction is also it is happens 18 grams. This is called law of conservation of mass. But here we are discussing about law of constant proportions, means definite proportions these elements are having. That means so if you cancel here with 2 table, then it will be 1 time, and if you cancel this one, how many times? 8 times. 1:8 ratio. So always that water molecule, in the water molecule, always in the water molecule, that hydrogen and oxygen, these two are having 1:8 ratio. This is called definite proportion. So what is the definite proportion of that water molecules? Always 1:8 ratio. We will see another example. For example, if you double it, here 2 hydrogens are there. So you take 4 hydrogens plus here 1 oxygen. So you should double it, 2 oxygens So how many water molecules here? How many water molecules it is happened? Only one water molecule. One water. So here you should double it. 2 water molecules. Okay. Now we see this one. So actually hydrogen weight is 1 gram. But how many hydrogens are there? 4 hydrogens. So 4 grams. And oxygen atomic mass is 16 grams. But here 2 oxygens. 32 grams. So now what second table, again we will cancel with the second table. It will be cancelled 2 times and it will be cancelled 16 times. 16 2s are 32. Again if you cancel 1. Again if you cancel. So always here how many water molecules? 1 water molecule. Here how many water molecules? 2 water molecules. Whatever it, finally you are getting 1:8 definite proportion. What is the definite proportion of water? If anyone asks you, then you should say 1:8 ratio. This is called law of constant proportions. So in this video we discussed about law of chemical combinations and law of constant proportions and law of conservation of mass. These 3 topics we discussed. So in next video we will continue this lesson. Thank you.